All right. So very excited now for this next presentation by Drummond Reed. As we've been going deeper and deeper into self-sovereign identity and trying to see the different benefits and value propositions of this, there's just an explosion of possible use cases and different things that we could do. So one of the toughest things with any new technology or opportunity is just having focus and focusing on real world problems that could be solved and things that could be solved, I guess, in the short term and other things in the long term. And so we wanted to explore what's possible, and we couldn't think of anyone better than Drummond Reed, the Chief Trust Officer at Evernham. Drummond has been in the digital identity space for, it's like quite a while, Drummond. Yeah, we're very fortunate to have Drummond here today, and hopefully everyone really enjoys and gets value out of this presentation. And just a reminder again, if anyone has any questions throughout the presentation, please write the questions on the chat within the Zoom link, and Drummond will try to address them as he's going through. So thank you. I'll give the digital floor to you, Drummond.
Thanks very much, Matthew. It's a pleasure to be here and speak with everyone, and to have Tim join us. I'm a huge fan of his work and the PCTF and the most recent version and all the work that he's done to make it both backwards and forwards compatible with what we're going to be talking about today, SSI. You'll see a number of the use case examples I'm going to bring up here reflect Canada because of its leadership in digital identity, and they just keep doing it. I don't know what's in the water up there, but it's fantastic. So yeah, let's dive into it. I'm not going to talk as much about architecture as I normally do here. I will cover the basics, but we're going to talk use cases and real problems that SSI is already being put to work to solve. So yeah, a little bit of my background. I have, as Matthew said, been doing this for over 20 years now. I've been to all 29 instances of the Internet Identity Workshop. It sounds like number 30 might be virtual. It's at the end of April, so we'll see about that one. I've been working on all kinds of identity standards, and in particular now, I've been working on was involved with verifiable credentials, but I'm one of the editors of the DID spec, the decentralized identifiers. That's the other key specification that's at the heart of what we're doing with self-sovereign identity. My day job is Chief Trust Officer at Evernym, but my night job is a trustee at the Sovereign Foundation, where I chair the Governance Framework Working Group, and that's why we particularly appreciate the work of Tim and everyone on the Pan-Canadian Trust Framework, because it is one of the leading trust frameworks in the world and an inspiration for our work as well. And I did a lot of work with the U.S. government on the early standards. I always like to call out that they helped fund both the early work on the DID standard and then on decentralized key management. So a number of governments are helping us move this all forward. So just to make it clear for everyone, so Evernym, we're a commercial vendor, SSI software solutions, and based on Sovereign and other Hyperledger Indie networks. Evernym contributed the original code and helped start up the Sovereign Foundation, but it is a completely independent international nonprofit whose whole goal is helping establish self-sovereign identity infrastructure that can be relied on by everyone, everywhere. Identity for all is our model there. And Sovereign in turn contributed the code to Hyperledger, where it originally became the Indie project, and then the crypto libraries were spun off into the Hyperledger URSA project, URSA. Highly recommended if you're into the crypto part of it. And then a third project was spun off called Hyperledger Aries for the agent and wallet code that is ledger independent. And so if I make references to the Hyperledger projects, it refers to all of those. So what Matthew and everyone wanted to cover here today, I'm gonna make sure anyone that's new to the general concept, we have a basic understanding together of verifiable credentials and the special governance frameworks, and then we're just going to talk about 5 major real market use cases, and I'm going to explain the use case in each case, and then provide a very specific example. And what I like about this and preparing this presentation is there are multiple examples in the real world out there. Not all of them are Evernham customers, but there are, not just like solitary examples. And so I selected ones I thought were the most illustrative that I could easily talk about. Some of them I just came from the Hyperledger Global Forum event in Phoenix last week, and wanted to highlight the last one. I'll be talking about a presentation that was given there. So it's sort of the cutting edge news. But I will mention other examples of each of these 5. And the second thing I want to say is there are probably at least 5 more buckets of use cases I could have chosen, but that would have taken too long. So I tried to pick the ones that represent the most real, pain points in the market that we are seeing today. So let's dive right into it, and start out with just some slides that I think many of you, if you've seen any of my work before, you've seen these slides where we make sure that the overall metaphor of what we're doing with SSI, verifiable credentials, is I like to, hold out a wallet and say, we've been doing this for quite a while, we just haven't been doing it digitally. And as credentials are moving on to devices like our smartphones, we are using wallets, we are using things like mobile boarding passes or mobile movie tickets regularly. That's a step in the right direction, but those are proprietary. And what we need to do is move to open standard digital wallets and digital credentials. And that's the work that's been going on at W3C. So this diagram is actually taken from the W3C verifiable credential data model 1.0 specification, which became a full W3C standard last November. So it's been all the way through several years of the standardization process. And this trust triangle is how all verifiable digital credentials work. They all have issuers that either, you can think if you're a physical wallet, someone issued you a credential that you hold in that wallet, and you go present to a verifier, such as a passport or a driving license, when you want to go get on a plane. The role here in the center of what's called the verifiable data registry is actually quite critical from a cryptographic standpoint, and I'll explain that a little bit more, just the high level, in this by moving to this next diagram. And again, I want to explain just enough of how verifiable credentials work, so that as we go through the 5 major use cases, you can see exactly where the technology is providing the breakthrough value. So this is, again, a little simplified geometric version of the trust triangle. And I want to make sure it's clear, what is the role of blockchain? Why is it a breakthrough in allowing us to move into verifiable credentials? And the answer is, it provides us a decentralized way to publish and verify the public keys and other metadata we need, so that we can digitally sign credentials in a way they can be verified. And to do that, the issuer of the credential is the party that needs to write what we call a decentralized identifier and the associated material, including the public key, to a blockchain designed for that. There are DID methods are called for many different blockchains. There are over 40 DID methods that have been created so far. And they can work with any blockchain. There's several that work with Bitcoin. There are, I think, 9 now that have been written for Ethereum. And then for other SSI specific blockchains like Sovereign or VerisOne. So the issuer takes that step to prepare itself. At that point, it can begin issuing credentials, verifiable credentials, in the W3 standard format. And what they're able to do is sign them with the private key corresponding to the public key with the DID on the blockchain. That DID of the issuer is in the credential, so that when it goes to the holder and into their wallet, the holder is now able to produce a proof of that credential. And we call them proofs because it's not the same thing as just getting a credential out of your wallet and showing it to someone in real life, because a digital credential with zero knowledge cryptography specifically, you can just prove what the verifier needs to know. If you're entering a bar, you can prove you're just old enough to drink. You don't have to reveal everything on a driver's license or a passport. So that's the proof stage. Now, when the verifier gets the proof, again, it has the DID of the issuer. So what it's able to do is read from the blockchain, read that DID document, get the public key, and then verify the proof. And we'll have a cryptographic certainty that, in fact, that credential and whatever was needed to be in the proof was issued by that issuer. Which gets me to the final 2 points. A credential only has value to a verifier if it comes from an issuer that they trust. So you need to have, there needs to be a trust relationship of some kind, but what there doesn't need to be is any form of integration between that verifier and issuer. This is what is so dramatically different about SSI infrastructure versus federated or centralized identity systems, where every verifier has to be integrated with either a centralized system or with an identity provider within a federated system. So this is why we believe that verifiable credentials are, they are a breakthrough. They are a paradigm shift in how we can do highly scalable and very flexible digital identity. So this is the the basic model. I want to point out just 2 other things before we dive into the use cases. And the first one is to clarify that under this model, although there are multiple ways of doing it, what we're doing in all the Hyperledger architecture is ensuring that all the private information that pertains to a particular holder of verifiable credentials stays off-chain, stays privately in their own wallet. And so you notice that there was a DID for the issuer. We do not require the holder to have a DID on the blockchain, because the holder is able, when it forms a relationship with the issuer, when it first needs a credential, for example, they will exchange what we call pairwise peer DIDs. And these are DIDs that are produced directly in the wallets of the 2 parties, exchanged together with their DID documents, and then kept in synchronization as either one of them needs to rotate keys. So this becomes a private pairwise connection and channel for communications just between these 2 parties. When the holder, for instance, first goes to a verifier who's requesting a proof, the same thing happens there. By default, it's another pairwise peer DID relationship. And what we're building up is a graph of all of our relationships, but each holder in the center of those is a peer with all the others, and these DIDs and both public and private keys stay entirely private. You'll never need to share those outside of that relationship, which means it's almost trivially easy now to authenticate and have a secure and private channel as you're sharing verifiable credentials or doing anything else with these relationships. So I'm going to make one more point, and then we'll take any questions about this section before we dive into the use cases, and that is the special role of governance frameworks. So in many cases, it's asked, okay, so if providers have to know, have to be able to trust issuers, and this is an example from, for instance, healthcare, where you've got a hospital that might need to know, okay, can I accept a proof of coverage from some insurance company? Well, can they know all the insurance companies that that they need to be able to access if it's a very large network? And so the answer you get to there is you add a second trust triangle. And we call it the governance trust triangle, because you're adding, again, another party called the governance authority. And this shows one example of how a governance authority could turn around and authorize a set of issuers to be, under what we call a governance framework, a document that they publish. Now, of course, the governance authority can be a government. And so you can see how the Pan-Canadian Trust Framework fits wonderfully within this model. And in that case, the different provinces, for example, would all be the issuers. Now, they don't necessarily have to issue a verifiable credential to each province. There are many other ways that they could authorize a particular set of issuers. They can publish a DID list directly, even in the Pan-Canadian Trust Framework or another mechanism, a whitelist. But they could also issue verifiable credentials. And now a verifier receives a proof from some holder from an issuer that it doesn't know directly, it can make a second request of that issuer. Can you show a credential that you're part of a governance framework that it trusts? And if you want an example, well, how does that scale? The largest trust networks in the world work exactly this way. If we took the example of MasterCard, for instance, it's a governance authority over the whole MasterCard network. It authorizes every bank that can issue MasterCards to what they call cardholders, which put them in their wallet. And then they go and use it at a merchant to prove that they're authorized to buy goods there. So what we've done with SSI infrastructure is we've generalized this so it can be used for any trust network of any kind of information at any scale, anywhere, all done according to open standards. So, so that I'm going to stop there before we dive into use cases and